Hi, this is Mr. T with a tutorial on solving exponential equations. There are two types of equations we can solve. If we look at the example problem I've written on the left, where we have two power expressions, if we can convert both bases to a same base, then we can solve them by equating the exponents. We'll demo that in a minute. The other two expressions or two problems have a single term that has an exponent, and on those we need to isolate that term and use logarithms to solve for x. So let's start with the problem on the left, and we have here 8 for one base and 16. Those are both powers of 2, so we can rewrite the 8 as 2 to the third power, and that's still raised to the 5x power, and 16 is 2 to the fourth power. Now, to simplify that, we use our exponent properties, and we have power to a power. We multiply the exponents. So on the left we have 15x, and on the right we have 4 times 3x, which is 12x, and we also have to distribute, so we have 4 times 4 is 16. Now, for these two expressions to be equal, since the bases are the same, we can just set the two exponents equal to one another and solve. So we would be subtracting the 12x, and we get 3x equals 16, or x equals 16 thirds. Okay, so this works when we have two powers equal to each other, and we can make the bases be identical. Okay, on these two problems we need to get the part with the exponent by itself first. So in this one we need to subtract 1, and then we need to multiply by 4 to get rid of the fraction. So I'm going to multiply both sides by 4. So we have now 4 to the 2x equals 16. Now, we could actually solve this one by writing this as a power of 4, but let's assume we didn't recognize that. So now we take the logarithm. Now we want to take the log of base 4 here, because the base of our exponent is 4. And whatever we do to one side of the equation, we must do to the other side of the equation. Over here we have a log of a base b, and we have b to the power, and one of the properties we have is that we just get that this essentially undoes the exponent, so we get 2x. Whatever the exponent is up here, that's what we get when we take the log. And on the right side, we would have to use our change of base formula, so we would get log of 16, base 10 log of 16 divided by base 10 log of 4. Now if we put that in the calculator, that's going to equal 2. So now we have 2x equals 2, and divide by 2, and we get x equals 1. Okay, lastly here we're going to add 4. So we have 3e to the negative x equals 13, and then we divide by 3. And we have now e to the negative x equals 13 thirds. Now here we're going to take log base e of e to the negative x. But if you remember, there's an abbreviation for log base e that's on the calculator that's called the ln. So I'm going to write it as ln on the right side. Here we get negative x equals ln of 13 thirds. I can use a calculator to calculate ln of 13 thirds, and I get 1.466 if I round it. And now I need to divide by negative 1, so I get x equals negative 1.466. And I hope those examples help you, and we'll talk to you on another time.